Hi everyone, today's video is going to focus on solving 1 and 2 step equations. Now again, I'm guessing that most of you have seen this. Some of you might remember it pretty well and some of you may have forgotten. The main idea here is to make sure we're all using the same vocabulary and that we have a common way for showing our work. So that's what I really want you to focus on as you're taking your notes, is really writing out the steps the way that I do and making sure we're getting really organized about showing our work. So first, in terms of vocabulary, an equation, so we say an equation always has an equal sign, right? Which is obviously different from the expressions that we were talking about before. Expressions did not have an equal sign, and equations do. Now, you're going to hear me talk about inverse operations a lot. So inverse operations are two operations that undo each other. So for example, if I have addition, its inverse is subtraction, because I know subtraction will undo addition. Likewise, multiplication and division are inverse operations of each other. So when we're solving equations, we're going to use inverse operations to get the variable by itself. So the first type of equations that we're going to solve, that's always the verb we're going to use here, is to solve. These are just going to be one step. In other words, we only have to use one operation to get the variable by itself. And a lot of these I'm sure we could think of or solve using mental math, but again, we want to get a format for solving these so that as our equations get more involved, we have a nice way of organizing our work. So one thing I always like to do to keep my work organized is I always draw a line through that equal sign to keep my left and right sides separate. Now, on the left side, I notice in this case that my operation is addition. I need to use the inverse operation to get x by itself. So since this is a plus 7, I'm going to subtract 7 from both sides. Oops, excuse me. Now, I know that 7 minus 7 is 0, so this is going to cancel, and I just have x left. I'm going to copy my equal sign. Now, I have to be really careful with my subtraction here. 4 minus 7 gives me a negative 3, and that's my answer. Now, one thing I won't require you to do, but I highly recommend that you do, is check your answer. When we're solving, there's a really easy way to know if we're right or wrong. What I'm going to do is substitute my answer into the original equation. So my original equation was x plus 7 equals 4. I'm going to take my solution from my problem, negative 3, and substitute it for x. So I would write negative 3 plus 7. Now, if I go into my calculator and I do negative 3 plus 7, I get positive 4, which equals the right side, and I know I got the right solution. I highly recommend you take the time to check your answers so you know, particularly on a quiz or a test, that you've done this correctly. Okay, so let's keep going here with number 2. I notice on the left side here, my operation is minus or subtraction. So I know I need to do the opposite. So I am going to add 12 to both sides. Now, if I did negative 12 plus 12, again, that gives me 0. That's why I can cancel that. I bring down my x, and I know 12 plus 3 is 15. So my solution is x equals 15. Again, if I were to check that, I would copy my original equation, x minus 12 equals 3. I would take my answer and I would substitute it, replace the x with that number. So 15 minus 12, that gives me 3, and since that's equal to the right side, I know I did it correctly. All right, we'll just go over number 3 and 4 on this page, and we'll save the next two for examples in class. Now here, I notice my variables on the left side, and attached to that is this negative 6. I know when I have an expression like this where the 6 and the x are right together, that's multiplication. To undo that multiplication, I need to divide by the coefficient. Now notice my coefficient was negative 6. That means I have to divide by a negative 6 as well. And I'm going to do that on both sides. Now a negative 6 divided by a negative 6 is just a positive 1. So really here I have a 1x, even though I'm not going to write that. And 48 divided by a negative 6 gives me a negative 8. All right, one more here. Now again, I find my variable on the left side, and I notice that x is being divided by 4. That's what x over 4 means. So to undo division, this time I have to multiply, because I know multiplication is the inverse of division. Now, 4 divided by 4, again, gives me 1. So I just have 1x, and I know x is equal to 20. So those are my one-step equations. I only need to do one operation to get the variable by itself. And again, don't worry about filling out 5 and 6 now. We'll talk about those in class when we're together next. But let's go ahead and turn to the next page. And we're going to talk a little bit about two-step equations. And again, we won't go through all of these examples. We'll just do a few to kind of get you going here. Now, sometimes when we're solving equations, it takes more than one step to get the variable isolated. And again, when we say isolated, we mean by itself. So in this case, we always undo the order of operations. So remember, order of operations when we're using the order of operations, the first thing we would do is parentheses. Second is exponents. The third thing we would do is either multiplication or division. And last, we would do addition or subtraction. Now, when we're solving, all of this gets reversed. So in other words, first I would undo any addition or subtraction. Then I would undo any multiplication or division. I would deal with any exponents. And lastly, I would do parentheses. So notice it's all in reverse order when we're solving, because we're trying to undo that order of operations. So let's take a look at what this would look like. And I think we'll only do 2 examples for the purposes of this video. So for number 1 here, if I look, when I'm solving, it says first undo any addition or subtraction. So I look in my problem and I notice that I have a plus 5. So I need to get rid of that first. So since I see addition, I know to undo, the inverse of addition is subtraction. So I'm going to subtract 5 from both sides. Now 5 minus 5 is 0, so that goes away. I still have my x over 2 equal to 11. Now I can see that once I've gotten rid of the addition or subtraction, now I can take on the multiplication or division. And my problem here, I have x divided by 2. To undo division, I need to use multiplication, so I'm going to multiply by 2 on both sides. Now 2 divided by 2 is 1, so I have 1x equals 22. And I'm done. Now, since this problem was a little more complex, I do want to check. So I'm going to do that quickly to make sure I took care of my steps in the right order. So I have x over 2 plus 5 equals 11 was my original equation. Again, to check, all we're going to do is we're going to take the value that we think x is equal to, and we're going to substitute it in for the variable. Actually, actually. This is a great example because I'm realizing I made a mistake here. If I were to plug in 22, I get 22 over 2 plus 5. I know 22 divided by 2 is 11 plus 5, which is 16. That is not equal to 11. So that means I did something wrong when I was solving. So now I need to go back and find my mistake. And that's actually the power of checking your work. I realize now that I made a mistake. I don't have the right answer. So I'm going to go back. I'm going to use a Post-it note here. You can kind of scratch off and put to the side. I'm going to go back and see what I did wrong. So my original equation was x over 2 plus 5 is equal to 11. So I'm still looking at my steps. See, I should undo addition or subtraction first. So I'm going to subtract 5 on both sides. And I'm realizing, let's see, 5 minus 5 is 0. I still have x over 2. But now I'm realizing when I did this, I never subtracted the 5. I was being careless and just copied the 11. So 11 minus 5 is going to give me 6. Now to undo division, I do the inverse, which is multiplication. And I get x is equal to 12. So now I'm going to redo my check step because I realize it kind of saved me from a wrong answer before. So let's see how this one works. My original was x over 2 plus 5 is equal to 11. I'm going to substitute my solution 12 divided by 2 plus 5. I know that 12 divided by 2 is 6 plus 5, which is now equal to 11, and my left and right side match. So I know I did it right. So that again just kind of shows us the power of checking our work. I was actually able to realize my answer was wrong and go back and fix it. All right, let's go ahead and do one more because this actually is an interesting example here. I noticed that my x's are on the left-hand side, but what I notice is I actually have like terms on this side. I have 7x, and then I have minus 4x. So before I do anything, I want to simplify the expression here on the left-hand side by combining those like terms. If I take 7x minus 4x, since this is a minus, I'm going to subtract those coefficients. So 7 minus 4 gives me a 3x, which is equal to 21. Now I just have my nice one-step equation left. To undo this multiplication, I'm going to divide on both sides, and I have x is equal to 7. Okay, so I think for this video, we'll leave that there. We'll start off class when we're back after the long weekend by going through these examples and making sure everyone's comfortable with that, and then we'll be working through some activities to do more practice with equations. All right, I hope you have a great long weekend, and I'll see you when we're back for the block on Tuesday.